Thank you, madam, for the nice introduction. So I'll be talking on the tropical Indian Ocean variability and its impact on Indian monsoon in a changing climate. So the outline of my talk, I'll touch upon some variabilities in the Indian Ocean and the mechanism through which the IOD forms and Indian Ocean basin mode forms, and the relationship between IOD and Indian monsoon, and other climate modes such as Equino and Indian monsoon. And as we are all seeing, that the climate change, what it can do to this pattern and the intensity of IOD and its impact on the different climate, the regional climate. See, if you look at this is the top one is the sea surface annual mean sea surface temperature. You can see the warm Indo-Pacific water that is getting expanded in the recent years towards west and making the Indian Ocean more and more warm. And right top is the annual precipitation. You can see the high precipitation over the warm tropical oceans, and this is the CMAP July precipitation, and bottom is the January precipitation. So you can see the patterns, and this is it's seen in GPCP as well. So I mean, they are all similar. So the climate variability such as ENSO or IOD can modulate these precipitation patterns a lot, and so we need to really understand the mechanisms and what will happen to the precipitation patterns in warming climate. Yesterday, Arindam had talked about the changing ENSO pattern and the ENSO monsoon teleconnections and the different mechanisms. Today, I'll be talking about the tropical Indian Ocean variability, mainly the Indian Ocean dipole and the associated mechanisms and teleconnections. So this is the leading mode of SST variability, or empirical mode analysis. So first UIF, you can see, which explains about 40% of the variability in the Indian Ocean, which gives you a basin-wide signal. That means the basin as a whole either warms or cools. And the second mode, which is more popular, which is the Indian Ocean dipole with an east-west pattern with the opposite signals of positive anomalies in the west and negative anomalies in the east during the positive phase of IOD. And the bottom panel, nice schematic, which explains the shaded is, that sea surface temperature pattern. So you have a cooler sea surface temperature in the east and warmer in the west, and you can also see a cloud pattern covering the Western Indian Ocean, India, and the North African region. Similarly, the opposite happens in the negative dipole phase, and the animation is the recent 2019 IOD event from its developing stage from June, July, August, September, October, November. This is a typical pattern of an IOD. And so if you look at this, there are different mechanisms which is forcing the IOD. The most popular mechanisms are, the major changes happens in the wind. Once the winds change, the thermocline get affected. The thermocline changes, then it can affect the SST. So the wind through thermocline changes can affect the SST. That is one feedback mechanism. See, another one is the wind also can modulate the evaporation. So the evaporation can cool the SST. So wind evaporation SST feedback is also very, very important in the IOD formation. See, another one is the Bjerknes positive feedback, which is essentially driving the El Nino, for example. See, you have this is the feedback, positive feedback between SST, wind, thermocline, and basically the SST gradient drives wind. The wind can change the thermocline. The thermocline then affect the SST. So there's a positive feedback, so which I will explain later. So what you see here, the wind surface wind changes in the different phases, and the thermocline changes you can see associated with this. So now the main mechanism forcing Indian Ocean dipole, so there is a large subsidence during the positive phase of a IOD. So this subsidence over the eastern Indian Ocean region or maritime continent region, so they trigger two anticyclones, one in the south and one in the north, and these anticyclones can force downwelling Rossby waves in the ocean. So the southern component is very strong, so which propagate westward and push the thermocline downward and favoring warming in the west. So once the west is warm, again the surface winds will intensify because of the SST gradient, and this affects the rainfall pattern in the west and eastern region. So this is the basic mechanism for the IOD formation. Now, if you compare the IOD formation mechanism with the ENSO mechanism, so they are in contrast. For example, in the El Nino phase, you get warm sea surface temperature anomalies in the eastern Pacific, whereas in the IOD positive phase, you get a cold SST anomalies in the east. So now, if you look at the wind pattern, the El Nino, you get prior to the El Nino formation, there is a trigger of westerly winds. Similarly, during the IOD phase, prior to the IOD formation, you will see the trigger of easterly winds. Now, if you look at the trigger in both Pacific or Indian Oceans, the equatorial region will have more magnitude of wind anomalies compared to the off-equatorial region. So they can actually induce in the Indian Ocean, they can induce an anticyclonic circulations. They can induce the downwelling Rossby waves both in the north and south. Whereas in the Pacific, it is the opposite. It can provide this type of wind shear can induce a cyclonic wind stress curl, and they will induce upwelling Rossby waves in the Pacific. So now, because these Rossby waves and they propagate westward and the basin is very small, they can, within few months, they can warm the western Indian Ocean and create an SST gradient between the west and east, and which will drive or intensify the easterly winds further. And this also is the same, like you can see, this is the climatological thermocline pattern. The west is shallow, deeper thermocline in the east in the Indian Ocean, whereas in the Pacific, you have very deep thermocline in about 200 meter here in the West Pacific and very shallow thermocline in the east. But this thermocline is a climatological thermocline get reversed during a positive phase of an IOD. And similar to IOD, the Equatorial Indian Ocean Oscillation or EQUINO, so that also provides an atmospheric component of an IOD. So this is basically explained through the outgoing long radiation difference between the west and east. So that explains very clearly on the equatorial winds. You can see here in the scatter diagram, the the bottom one is the equatorial winds, and this is the YLR based index. You can see they correspond very well. That's also, this is very close to the, very well correlated with the Indian monsoon rainfall. Now, if you look at the first mode, which explains about 50%, 40% of the variability, this is mainly explained by the El Nino. So this figure is a correlation between the NDJ, November to January Nino 3 SST anomalies correlated with the global SST anomalies. You can see a pattern. So here you see El Nino, and you will see the corresponding warming over the Indian Ocean. Similarly, that same thing can be seen in the 3.4 index also. So they provide similar pattern, suggesting that the first mode of variability is mostly explained by the El Nino Southern Oscillation, and through the atmospheric bridge, you have convection in the Pacific, Central Pacific, and subsidence in the Indian Ocean region, and which suppresses convection, and the short radiation will increase. All these they are favorable for warming the Indian Ocean. So the Indian Ocean warms. Whenever there is a El Nino in the Pacific, within few months you will see the Indian Ocean also shows similar pattern with the warm anomalies. Similarly, during a La Nina phase, you will see the basin-wide cooling. And what is important is, if you look at the ENSO El Nino evolution, so it's evolved about a year back, and it persists for a long time. And this is the next year. By April, I mean, they decay. But in the Indian Ocean, so this is the simultaneous the tropical Indian Ocean SST. So they also evolved parallel to the Pacific warming, but they persist for more time. So this is even during the next monsoon period. So this is an important the mechanism which can affect the Indian Ocean and Indian Ocean regions. So now, if you look at this, this is the changing pattern in this. So that this is a special pattern of TAO response to ENSO in prior to 1970s or 1980s or beyond 80s. You can see that a lot of changes in pattern, and right from the June, July, August, and if you see the peak period and the March, April, May following ENSO, you can see large changes in the pattern. For example, one of the significant change in the recent years, what we see is there is an asymmetric pattern of a C-shaped pattern of the wind happening in this region. That is also closely associated with large warming in the southwest Indian Ocean region. So this is very important because these similar signatures you can see in many fields like the sea level pressure, SST, and the rainfall pattern. So this is going to affect the large scale patterns over this region. And another thing what you can see is, so these are two periods. In the recent years, if you see there is a dashed line, the warming pattern in the North Indian Ocean has changed a lot, because the North Indian Ocean was not warming in the ENSO phase, but it started warming only after the ENSO decays. And whereas in the south, if you see Southern Ocean, see these are the dashed line is the recent one, and the thick one is darker one is the prior to 70s. So what you can see is, so this warming in the south is happening much before the previous era, and it's much intense, and this is persisting even more time. So one of the the cause for the North Indian Ocean warming is now coming directly from the tropical ocean, rather Indian Ocean, rather than from the Pacific through atmospheric teleconnection. So now the ocean dynamics play important role in modulating these changes. So these changes have huge impact on teleconnections. If you look at these ENSO teleconnections, say when the Pacific warms, the tropical Pacific warms, so there is an anomalous cyclonic circulation as a Gill's response. So these circulations will intensify the trade events over this region because they are easterlies. So they cool this region because of more evaporation due to stronger winds, and this cooling will trigger an anticyclone in the west, and this anticyclone will cool this region, eastern region, more because they are easterlies, whereas in the west they are westerlies or southwesterlies, and the climatological northeasterlies get reduced, and so this region, the Northwest Pacific region, gets warmed up. And you can also see in the IOD time, we saw that there is an anticyclone, and this anticyclone can generate Rossby waves. And these Rossby waves will warm this Southern Ocean. And now with the warming, now the Northwest Pacific anticyclone, so they get extended to even Indian region and play important role in modulating the monsoon rainfall, because these patterns persist up to even monsoon time. So in monsoon time, you have warming in the Indian Ocean with this feedback. And also the Indian Ocean can feed back to the Northwest Pacific and modulate this anticyclone in the Northwest Pacific, and so they can play an important role in controlling or modulating the rainfall patterns over both South Asia and Southeast Asia. And see, this is the way they are tied. You can see ENSO time scale persist up to the next March, whereas IOD is a very short-lived one. Maybe October, November they are gone, but immediately after that, when ENSO is there is a basin-wide warming, and they interact with their feedback Northwest Pacific, and say both Northwest Pacific anticyclone and the Indian Ocean basin mode persist up to the next June, July, or August, up to August. And so these easterly winds we were talking about, and the Rossby waves, even the easterly winds, they can the Ekman transport associated with these easterly winds can also feed on the downwelling Rossby waves. So the downwelling Rossby waves are now forced both by the wind stress curl, the anticyclone, and as well as the Ekman transport. And what is more important is, if you look at the PC, this is the SON PC, the September, October, November SST EOF, and if you regress the PC, you can see the strong winds and SST cooling here and warming here. And this is the picture of the surface of the ocean up to 200 meter or 250 meter. You can see around 100 meter, you will see strong warming in the west and strong cooling in the east. So this is the typical pattern. So, and this is the second mode, which is also showing, the strong cooling in the east. And you can, this is the correlation between the subsurface or sea surface height and SST, which is very high over this western region, suggesting that any wave activity in this region is going to impact the surface. So, which is any changes, that is what later I will show you how these waves are getting modulated, and if the waves are getting modulated here, they can interact with the surface, and the entire western region can warm and modulate the air-sea interaction over this region. We also reported the north-south mode in the subsurface, in contrast to the surface, where you will see an east-west mode of variability. In the south, in the subsurface, you have a dominant north-south mode, which is also very important in controlling the IOD and the other processes. So you can see this is like a typical example of the Rossby waves, propagating upward, affecting these are temperature anomalies. You can see from September 2006 to January 2007. You can see how the anomalies which are seen at 100 meter or below, they get propagated to the surface with the Rossby waves. And this is seen in the composite of all the IOD years. You can see that the similar pattern is seen. And this also the similar, the strong north-south pattern is also seen in the sea surface height, the EOF pattern. So another important thing, if you see, if you recall that the basin-wide warming is triggered by or explained mostly by the ENSO forcing, because we could see that in the 3.4 correlation. But if you see here in this, we took the subsurface PC and regressed with the SST pattern, and it's a partial regression or partial correlation with no ENSO. Even when the ENSO signals are removed, you see you will get a basin-wide warming. That is suggesting that you don't really require an ENSO to force the basin-wide mode. So you need only the subsurface mode of the variability. So that is the case, ideal case of 2019-20, where you got a very strong IOD when no ENSO or activity was on, with a subsurface mode and a basin-wide warming. And the IOD can also influence other climate modes such as ENSO, the positive phase of IOD. So you have large subsidence in the eastern regions that can trigger westerly winds, and that can enhance and sustain the ENSO. So like ENSO trigger and enhance IOD, the IOD can also enhance and sustain the ENSO. See, now there's another one, like during the basin-wide warming phase, that is initially could be due to the ENSO forcing, but once the Indian Ocean is warm, so they can trigger easterlies in the Pacific, and then the easterly winds can then trigger more cooling due to the upwelling Kelvin waves, and you can trigger La Nina force, La Nina. So that is why so every El Nino is followed by the La Nina also. So look, that is. And similarly, the Rossby wave train induced by this Rossby wave train induced by this IOD can actually trigger the subtropical IOD due to this. So the IOD has influence on many climate modes, in addition to the changes in the rainfall pattern. You can see IOD in climate change scenario. See, that's an important question. What will happen to the IOD when the globe is warming? So the studies have found from the CMIP models that the strong positive IOD events are increased in a warming climate. So that is very, very important. So now, why strong IOD events happen during the global warming scenario? Because this is the multi-model, it's 20 CMIP 6 models. The average mean state changes from the present day climate. You can see this large warming in the western region. You can see this is a SST change. Similar to the SST change, you will see the change in wind pattern with the large easterlies over the equatorial Indian Ocean. So now, this the SST gradient triggering the winds, they are favorable for IODs. So that is how, and the other components like this is the changes in the latent flux, this is the changes in the total latent flux. So they are all favoring the formation, the formation of strong positive IOD events. So now, so what are the characteristics of strong IOD events? We have looked at the strong and weak IODs, and this shaded one is the SST in the strong IODs, and these are the right panels are weak IODs. You see a lot of changes in the strong and weak years, and the dash the contours are the Rossby waves are waves. You see there's large changes in the wave patterns, the ocean dynamics in the strong and weak years. And similarly, the similar things you can also see in the forcing, like short radiation or latent heat flux or the wind patterns. So you can see in all. See, like here you can see the wind patterns in the strong years. You will see a lot of easterlies, strong easterlies, whereas in the weak years, the easterlies are only seen in the western, in the eastern Indian Ocean region, whereas in the strong case, strong IODs, you can see the easterlies extending up to the western Indian Ocean, so which can modulate the dynamics. That is what we are seeing reflected in the waves. And you can also see in the rainfall pattern. See, like this is the most important thing. Like see, this is the IOD impact on monsoon. See, you can see that there's the rainfall over the Indian region is marked green. You can see that there's large rainfall pattern associated with the strong years compared to the weak years. So weak years you don't see such anomalies. See, during positive strong IOD years only you get more rainfall. So that is another thing in the climate scenario when IODs are going to be stronger and stronger. So these are going to get affected. Not only see the positive impact on the Indian rainfall, but in the other regions like see strong years we have seen the changes in the water circulation. See, like there is a trigger of Indian Ocean water circulation during the strong IOD years with the convection over the Western Indian Ocean with large subsidence in the African region. So which is going to affect the rainfall pattern or reduce the rainfall pattern in the African region. Whereas normal IODs, so you get, for example, here in the moderate or weak years, so you get convection over the African region. So the African region get more rainfall. But whereas in the case of global warming and the stronger IODs, so the Indian Ocean water circulation, they can trigger subsidence and reduce rainfall in African region. So they are very important. And you can also see the patterns like how the strong and moderate events, so they impact both the surface, these are surface features, and the ocean subsurface, and this is during the weaker period. And see the processes. For example, the winds, the advection, see the water transport, etc. The blue one is like the present day, and the red one is future for the next century. You can see in the easterlies you can see the change difference compared to the previous decades. There's large changes in the large easterlies you can see in the future projections. So can I continue or I should stop at this point?
Yeah, you can continue for another few minutes, because it's such an interesting thing. I don't want you to break up in between. So please continue.
I'm sorry. I will cover one or two more slides and then stop. Yeah. Okay.
Sure.
Okay. Now, if you look at the zonal wind, you can see the change, the projected change in the next century is large. Here it is 0, and this negative side is easterlies. Positive side is westerlies. So now, if you see the easterlies are going to be very, very strong in the future, and for the positive IOD, whereas in the weaker or other events except the extreme events, you can see you will see the change is not much. So the large, the extreme or strong IOD events which are projected to increase with the climate change is going to induce large studies. And similarly, you can see the similar changes in the westward ocean heat transport, and also rainfall pattern. You can see this is the in the control present day control simulation. You can see this is the blue is positive rainfall and red is negative rainfall, and with the climate change. So you can see there's large change, and the difference is plotted here. You can see in Indian region or the north, you see mostly a positive change, more rainfall, and whereas in the African region, what we have seen before, and in the south, so they're going to be uh, deficit rainfall IODs. So you can see that this pattern, these are all shown in different basins like Eastern Africa. It's very clear in the study by other studies also show the similar same thing. Yeah, I think I will stop because I'm sorry I have more material, but yeah, I will better take more questions.
Thank you so much for, I mean, like, it's amazing.
I would like to summarize, like, the IODs are going to be stronger, and they are going to impact rainfall over the region, the adjacent region, especially the Indian region, which is going to be more positive, and whereas in the African and Indonesian region or Australia region, it is going to be more deficit. Okay.
Thank you so much, sir. It's such a wonderful presentation that I don't feel like interrupting you in between, and I feel that to keep on talking.
I'm very sorry for that.
Especially this, because yesterday we had a presentation by Dr. Anandan Chakravarti, and the way he explained, I mean, like, so many questions were raised in my mind. And today, I think absolutely the way you presented everything is so clear, like a picture to me. So I am very sure that even the youngsters would have got benefited by your presentation, especially the understanding of easterly, westerly, and anomaly, anomaly, and then how this IOD field work, Indian Ocean Dipole works. So I thank you so much, and I invite youngsters to have questions. We have some time for questions. We can take a couple of questions from the young researchers. Please raise your hand, or you can write in the chat box if you have any questions. I request, I request our young researchers to ask something, clear your doubts if you have any doubts. Such an interesting lecture it was, and I really appreciate if you ask the questions. So much of work has been put in this work.
Maybe they understood all, because I was told that there are a lot of youngsters, so I tried to make it simpler.
Exactly.
They understood all the things.
Okay, thank you so much, sir. I thank you.
Thank you.
There are not any questions, and then we can move forward for the another presenter. Shakil sir is the last one. We have one more presenter. So now I request Dr. Parveen. Dr. Parveen.
Hi.
Yeah, we cannot see you. Can you switch on your camera for some time?
Yes.
Yeah. Hello.
Hello again.
I have already given your introduction to the people just before the earlier presenter, because he was facing some problem to connect with us. So I thought maybe if you can present. So your introduction was given. So I just a couple of lines I can talk about. So Dr. Parveen is from University of Northern British Columbia, Canada. She is a meteorologist with over 15 years of research experience on extreme weather phenomena resulting from air-sea interactions and their response to climate change. And her work focuses on using numerical weather predictions and global climatic model to investigate the structure and dynamics of extreme climate events. So I would like to request Professor Parveen to please share your screen and your research work with our youngsters.
Sorry, I can't share my desktop.
Can you see your on your screen? Can you see it at the right hand side?
Have you connected through browser or the
I found
Steam?
it, but
Connect through application.
Have you downloaded the application, Parveen?
no, I'm connected with web.
Browser. You have to connect with application. Then only the share thing will come back.
I'm
In
so
browser, it
sorry.
is.
I'm trying to
Okay.
share my desktop.
You just try to first you try to download the application and then share your screen. Take your own time. Dr. Parveen, you can take your own time. You can download the application and then get connected with us. So maybe if Professor Shakil Ahmed is around, maybe we can invite him for the presentation before you share your screen.
Okay.
Yes, yes, I'm here. Good afternoon, everyone.
So, sir, you are here.
Yes, yes, I'm here now. And but then let me see if the sharing maybe because I have not also used the application. I've used the browser.
Okay, okay. Then you may also have to
You allow
download
me
the
because
app.
I cannot share. The share is disabled actually. Sharing.
That is sir. That is Microsoft feature, sir. You have to use the application.
Oh,
In
I see.
browser,
Then
it won't.
I too have to leave and restart now. Okay. Okay. Let me. I'll then leave and then.
Are you able to download the application? Dr. Parveen? Maybe she's she's there.
Then she stopped that. She disconnect.
Uh, Hello.
So maybe it,
Uh,
yeah.
yes,
Yes.
I have now come through the application. So, but I am not able to. I will not be able to share because share is not enabled. Can you?
No, 1 minute. Sir, we will give you
Can you
presenter
allow?
permission. 1 minute.
Yeah.
Okay,
So
sure.
just wait a minute. We will give you the.
Oh, okay. Thank you.
So, without wasting any time, so I can request Professor Shakil Ahmed, a distinguished earth scientist specializing in groundwater hydrology with over 37 years of experience at CSIR, National Geophysical Research Institute, Hyderabad, India, and as M.K. Gandhi Chair Professor at Jamia Millia Islamia University, New. He has led numerous national and international projects, including India's National Aquifer Mapping Program and established the Indo-French Center for Groundwater Research, serving as its founding head for 2 decades with nearly 200 SCI publications, 5 books, and 43 doctoral pieces supervised. Professor Ahmed is recognized as one of the leading publishers in groundwater hydrology in the Indian subcontinent. He has received prestigious honors and awards. The list is really long to see, so I'll skip it. You can Google it. And so currently, Professor Ahmed is a visiting professor and consultant at the Islamic University of Science and Technology, Jammu and Kashmir, heading the establishment of the Center for Disaster Risk Reduction. So, sir, you are most welcome to present your make your presentation.
Yeah.
Okay. I am sharing my screen.
Yes, sir. We can.
Is it okay?
Yes, sir. Yes, perfect, sir. We can
Oh,
see.
that's nice. Thank you so much, and good afternoon, everyone, again. And the title of my presentation is Tackling Water Disaster Through Geoscientific Knowledge with Groundwater as a Rescuer. So I have, of course, chosen this title with some thinking, and I'm sure like to have a little discussion on these a few words which I have written. Of course, most important, water disaster is one thing, and then geoscientific knowledge is another, and then of course the groundwater. So these things I'll be speaking, and let me tell you that yesterday I listened to all the lectures, were very nice. In fact, but then one thing which was disappointing that these young scientists or young researchers, those who are participating, they are not very active. Actually, normally my habit is that I take the class and then more I tell, but I listen also from the participants. So I don't know how can I do that in the online meeting, but I like to question. I like to question you also. Is there anything to ask me? Okay, well, let's start that. I'm very happy to know that there is many lectures have gone on the climate change. So I'm definitely not going to talk on the climate change processes and particularly I'm going to talk on the impact of the climate change and on water. So let's start with the world water disaster. And I hope you're able to see my second slide. It's okay. Everybody's seeing my second slide. Next slide. Hello. Hi. Everybody, anyone know? Someone is not listening? No one is listening? Or?
Yeah, I think we can see that. Yeah, we can see.
Right, because sometimes it happens that slide doesn't change when I can see whether you don't see it. Okay, you're saying it's very nice. So what I can show here, I can tell that water and disaster could be synonyms. That you see that even if you have too much of water, normally if something is in excess, it's a good thing. But then if you have too much of water, it is not good. You can see that over the flood and the tsunami, which is not really acceptable. But if you have too little of water also, let's say, for example, over here, the drought as well as this drinking water supply crisis. See, in this case also it is a disaster, in fact. And in addition, if suppose the water is contaminated, this is also disaster. You see, this is a picture over here that this hand pump is there for drinking water, but then there is a cross, red cross over there, that this water is contaminated and you should not drink that. So that's why I told the disaster is very, very near to close to water, and that's how we will discuss this and then see that how we can reward. Now let me move further, and because many people have already talked this climate change. That climate change has existed now. No need to prove that also. Now we have to only see the impact. Now, in addition to the impact, yesterday some discussion was there on that water resources, how the water resources, of course, is very well impacted. In fact, whether the rainfall changes and temperature changes, please. But let me show you some more constraints that India has got. Of course, there are many possible information. India has got this map is very clear, very well known to you all. This is nothing but the rocks over here. And if you can see, the two-thirds of the country is covered by the hard rock, and hard rock normally are complex. Because the word hard itself is not good. The except this portion which is called bowl of water, but it's not like that. Well, it is alluvial region. But this is something which we cannot change. Now, let me come to another map. This map is the annual average rainfall of the country. Here also you can see such a large variation, right from 200 millimeter annual rainfall to around more than 4,500 millimeter rainfall over here in this side as well as this side. Then in addition to these two, we have another very specific constraint of that. This is the density of population in India. Now India has crossed China also and is the highest population in the world and about 1.45 billion. So what I'm trying to say, these are really the constraint in managing the impact or managing the water resources. Why? Because all these three comes into picture. Now, this is something which we cannot change. This is already fixed. We can't change much. This is something also not in our hand, but then very, very largely impacted by the climate change. This is something which we can change, but not easy. But of course, we have to know anyway. We are not going to change anything, but I'm going to bear with this and the thing. Now, I'd like to just share also this thing already discussed yesterday that what are the impact of climate change on water resources, particularly. And you see, this is the first one is very important. Yesterday, Dr. Rajivan also was showing that the annual rainfall, if you see the scale on the time scale of annual, perhaps you don't find any change. It's more or less constant and the average is flat. But the way it comes, the intensity and the number of days of the rainy days, etc., have been changed a lot, and that's how it is. Thus, what is the result of that? Is the surface runoff will be very high, and if surface runoff will be high, obviously groundwater recharge will be less. Because I'm going to show you next slides or other slides that how this happens. And of course, temperature high will increase the evaporation. And then glacial melt, all those things will increase this seawater intrusion. And all these have got the negative impacts only on the water resources, on the livelihood actually. Okay. Now, let me explain to you in a different way. This is called hydrological cycle or water cycle. It is very clearly known. Everyone who studies science had to go through that. What I'm trying to convey to you is the two circles. The two circles, I cannot discuss the entire cycle, it takes a lot of time, but this circle is the groundwater and this circle is surface water because all the evaporation goes here like that and comes back to the earth and sorry, and then it comes to it goes as a surface water as well as it percolates and goes as a groundwater again meet the oceans. This is why it is called cycle. Those who have not realized that actually. Now, what happens? These two circles, if their limit is fine, but suppose if this becomes the situation that one circle becomes bigger, another circle becomes smaller, or this becomes the situation, the other circle becomes smaller and this circle becomes bigger, then there is a problem, and this is what we have to manage and tackle and manage, of course. Now, this is the real data of Hyderabad. Normally, you see the rain from in India comes from through the monsoon, so it rains from June, July, August, September, or sometime October also, either 4 months or 4.5 months, etc. Like that. This is about 1984 to 2004, almost 20 years data of the monthly rainfall each month, each year. For the month of June each year, how it rained, July how it rained. So you can see the variation, and instead of discussing very detailed. What I can see now, there has been a shift to the monsoon, which has been discussed yesterday also, and extreme events have come now. That's why most of the rain comes in the later part of the, if you see the year in 2000 year, this half part, less rain is here, more rain over here or over here is there. And that now I think it's very easy to understand that, but I can explain that if 10 days rain come in one day, so obviously there will be a lot of runoff and the water will go to the streams, to the river and ultimately to the ocean. And the one Acharya was showing the other circle, it will not be able to percolate in the ground. And if it is not percolated, then it will not form the groundwater. So, finally the runoff will be more, surface water will be more, groundwater will be less. And that's why you see the second picture, the groundwater recharge has been decreasing as per the year from 2003 to 2013 tax. Like that. This is real data actually. So what we do actually now, there is a cartoon here, and the left side and right side, I discussed this. The left side, of course, it's for discussing it's okay, but then it's not possible. You cannot do the cloud seeding, and all those things have not been very easy. But then what we have to do is the right side. The right side is that normally you didn't want to rain, you wanted to avoid the rain. Now this time has changed. Now the rain has to be captured. The rain has to be captured and it has to be stored. Right. So now here is your rainfall and what is this? This is a storage. Now I'll discuss much more on this storage. So that's why I'm telling you right now, we will discuss exactly what is this storage. Of course, in this cartoon, it's okay, the drum is there, but the drum is not enough for a bigger problem. So, but then this we will discuss what is this storage in fact. That storage is actually the groundwater. Because it is very clear now, I have already discussed that due to the impact of climate change, a lot of surface water is generated and the surface water will be very soon going away from us and it will going to join the ocean and it will be lost for us. The groundwater which should have been with us is not the case. So what now obviously what I'm writing here, valuing the groundwater, we have to value the groundwater and we have to enhance the groundwater. How we will do that, we'll have to see this. Let me, before that, I explain that what happens with the groundwater. There is a lot of misconception about the groundwater, and that's why there has been a problem that to study, to understand the groundwater or to enhance the groundwater. That's what. So I'll just discuss in a couple of slides. You see that this is the hard rock region that I'm showing from the hard rock side because soft rock or alluvial is much simpler. This is complex. In fact, under the ground, in the subsurface, the water remains in a very limited area. You can see that in the volume. And the top is the skull, weathered rock, and then fractured and fissured rock, normally in hard rock. So the water, the groundwater remains only in the fracture. Above that is, of course, a little bit there in the weathered portion, which behaves like a alluvial region over the soft rock. But then what the people do? You need water because you have a crop, and you need water, so you have to pump. Now there is a pumping technology, so you pump it. But the problem is that the people don't know because you are here, you don't see what is inside unless you apply some other procedure like scientific procedure and all that. So this is an exact data actually from an area near Hyderabad. In 1980s, there were two bore wells, one over here and one over here, two bore wells, and mostly the water was drawn for agriculture from the dug wells. But the way, because you have the pump, so you pump that, the limited water is there. What happens this time? This water has gone dry completely because you have pumped much more than the recuperation. And at the same time, if you see the left-hand side, there were two bore wells. Now there are many more. I don't think maybe 20 over there in 10 years. Then another 5 years, what has happened? There have been a lot of bore wells and they started pumping. And what happened? The dug well completely gone dry. And even because the technology exists, so you have drilled the bore well again over here. But that bore well also because of heavy pumping, gone dry. If it gone dry, there is no crops now. You can't grow the crops now. So what is the next step? People definitely you need water. So people have gone even again in the next 5 years. You can see from 2 it has gone to several hundreds. But at the same time, technology is there, so people have drilled deep borewell and started pumping from the greater depth. So they started pumping. Now you see that what will happen next in 10 years further. All these have been pumped because the way of pumping, the speed of pumping is very heavy. All these been at the same time. This has been increasing, and I'll tell you finally in 10 years from now, around now also it's around 1,000 borewells are there, and you just see what has gone wrong. The concept which is not clear to the farmers or the people that you are drawing from the same system, whether you are drilling one borewell or 935 borewell, the water source is the same. So if you are drilling 900 or 1,000 borewell, you are simply wasting the money. you will not going to get extra water. The water will come from the same source, same volume there. So that is what the misconception is there. The people should not do that. And what is our conclusion is that and the problem is that the uneven spatial distribution of water resources is there, which make the misuse of the resources. So we need a better groundwater management with a greater thinking, and that's why if you see the title also is that with the scientific, geoscientific knowledge, that what I have shown you in the picture, that is the geoscientific knowledge which people don't have. Let's proceed further. And again, three more points are there that we need the management now. We don't. India, let me tell you, India is not a water-scarce country compared to so many other Middle East countries and all that. But we still have the water crisis because of the population and because of the mismanagement. So we need a rational management of the groundwater as much, and that is what is important. So because today you can manage, but tomorrow you can't manage that. So sustainability comes into picture, and for that you need a reliable and detailed knowledge of the system. That is the subsurface. And again, of course, there is some technologies called modeling, that is simulation of flow and mass transport, so that you can see what is the stress is going to be on our system and how the system is going to behave in future, etc., etc. Now, another thing is that again, I go back to the impact of the climate change. I have already discussed that impact of climate change on water resources is that more runoff generation is there and less groundwater recharge. So runoff generation, of course, water availability is there to us, but that will not stay because you cannot store them in open space like lakes or ponds or talab or cheru, whatever you call it, because of several reasons. Number one, you need space. Space is costly now. Plus, like for example, India is a semi-arid country. 60% of that will, whatever you state, 60% of that will go away. Evaporation also, because the climate change impact is on temperature also, and temperature rise will enhance the evaporation. So whatever you will store on the surface will go, more than half will go off from you. You will be losing that, and you need the space. And if you store, let's say, underground now. Now I'm coming to the subject. In fact, if you store the underground, that means you enhance the groundwater recharge, enhance your groundwater. Because groundwater has been depleting, I have shown you in a graph also, is because of the impact, because of the rainfall, the way rainfall has changed, it doesn't allow the much percolation that was needed earlier, that was done earlier. So the groundwater has been decreasing. And now let me, before going to that, how do we enhance the groundwater? We can tell that, I can tell you that groundwater is, storing in the groundwater is useful or important because you don't need space because it is under the ground. It will not be evaporated because it is under the ground again. And it will flow very slowly. It will not go very fast as the surface water. Surface water within a few days or months it will go and meet the ocean. The groundwater will take years perhaps to go and meet the ocean. That also goes, of course, to the ocean ultimately. But it will take much more longer time, and then it will spread over the area somewhere. Wherever you need, you drill a borewell and you can use that. You don't have to transport that through surface canals and all that. So it is all those advantages. It is very important that we should have groundwater and maximize the groundwater. For that, you have to enhance the recharge. Now, let's see how to enhance the recharge. Of course, the third point is there that for that, you need the detailed geoscientific knowledge. That is the knowledge of the subsurface. Now, let me just show you very quickly what is the constraint. Now, you see, even subsurface is so heterogeneous. Over here, there will not be any population. Over here, there will be a lot of population, of course. But then I mean, how to simulate that? I mean, no mathematician can really simulate that. It's so complex. Now, let me go another one, of course, similar one. And over here, this is a different rock. This is a different rock. It has got a different property of percolation. It has got different property of propagation. It has got a different property of percolation. So, accounting them or estimating them is not an easy task. You need a lot of geoscientific knowledge for that. Over here, there are the quartz. You see that this is a different one, this is a different one. So, a lot of heterogeneity is there. So, this is only the surface side. Now, let me go underground. Oh, this is again surface side, but then we go underground. You see that? Luckily, in India or in some places, many places, you have a large diameter because in old days, this was the only possible way to exploit groundwater because there were no drilling technology, there was no pumping technology, so people used to do with the hand. they removed the earth material to some extent as far as they found the water. Of course, it would have been something around 5 meters or 20 meter or 30 meter or so. 20 meter is enough because you can't dig more than that with the hand. It was very hard to do that. What I'm trying to tell you, it is very complex. You see, water will not be in this part because this part is a massive hard part. There's no space for water to stay there. But luckily, fortunately, there is a lot of very big space over here. The skull fracture, very big space over here. But then if we try to simulate mathematically, it will be very hard to how to generalize that, what equation we apply that, because then you can capture all the direction, all the sizes, etc., etc. So complexity is there, no doubt in that. I'll show you a few more over here. Same thing in one side, in a large one, and from for this nature. And then they percolate down over here. Or you see all the dug wells are, these are the real pictures. All dug wells are dry. There is no water over. The water has gone down much more because there is hardly any recharge and pumping is much more over there. Over here also. So all those uncertainties are there. There are some horizontal fractures again over here and over here. And this is a pegmatite vein, which of course also plays a role in flow and transport everything. There are some fractures over here. Some fractures is a big one, so one can go inside and study also, no doubt in that. So now, yeah. So now, how do you tackle the groundwater? Because now it is decided that we have to capture the rainfall, which comes in a very intense way. Otherwise, it will be lost, and then we'll have a crisis. So to avoid the crisis, we have to capture the rainfall, and we have to store that rainfall under in the subsurface as the groundwater. So now I have shown you some real picture, but what you have to do that you need the groundwater, which is making invisible visible, because groundwater is under the ground, so it's not visible. So how do you do that? Are you like to do that this way? You just sweep inside the ground and you can see that, and you can make the groundwater visible. It's not possible. Of course, don't try that. But then the way that you can do that through the scientific knowledge, that you may apply some scientific procedure, scientific method and surveys to find out the knowledge of to have the knowledge of groundwater and its groundwater system. So that I will tell you. I'm going to, whatever time is left now, I'm going to tell you 2 points. Number one, the misconception and misuse of that. I mean, unless you have, because that's what my title is that, through the geoscientific knowledge. The geoscientific knowledge is very important. Now I'm going to show you one a real case study. Here there is a pond here. It is very common in South India where hot rock, because the pond is there and the rainfall that occurs, it comes through the streams and then stay in a pond. Pond has got its deepest point. Sometimes this side is some sort of barrage, because we try to force the water to stay over here, as I told you earlier. So it is this deepest point here. So normally what happens, this is upstream, this is downstream. So if the rain falls, naturally the water will come and will stay here. So obviously this water will evaporate also as well as percolate inside. Now forget about evaporation. Percolation will depend what is the volume over available here and what is the permeability, vertical permeability to percolate that. But then another important point is there, which we usually forget. In addition to permeability, you need the space, because suppose you are eating the food and somebody is forcing you to eat the food, but your stomach is full, then why you can't eat anymore? Exactly same thing applies over here. That if this water has to percolate inside of the groundwater, you have to have a space, which you don't know unless you have the knowledge. You can't see that. What we have done, we have used the geophysics, I'm sure geophysical investigation many people may not be knowing, but let me tell you, it's very easy. This is electrical method. We pass the current inside the ground, and we throw the measurement of the potential, and we calculate the resistivity, and based on the resistivity, we infer that it is a hard rock or it's a soft rock. Like tell you very quickly here, this color shows that it's a massive rock. There is no question of any water over here. Whether these are the portion where the water is possible to stay and to flow. Exactly, this is at one two dimension of course in one place, another place and third place. And I'm going to show you in 3D now. The same tank is here. The first one done over here, second one done here like that. Now you can, if you visualize the three dimension, the point where we have a deepest portion of the tank doesn't have a space you see here. Very massive rock, which we were not able to see in the beginning from the naked eye. But from this geophysical investigation, it found that this deepest point has got hardly any space to percolate and have very massive rock, rather than this point, which is upstream, has got a lot of portion where water can percolate. So what we did then, with this knowledge, we try to put a barrier over here so that the water first comes, stays over here rather than going to the deepest point, because if you don't do that, obviously by the nature, it will go to the deepest point. So, of course, I'm not going to show the detail, but we have, through as per modeling, we have simulated the recharge and we found that if you do this sort of intervention, we get the recharge enhanced to 3 times, more than 3 times. This is without the intervention, this is with the intervention. So if you do that, so that's how, I mean, what I'm trying to conclude here, that unless we have the geoscientific knowledge, we cannot do this exercise and we will be losing always and we'll be misguiding to now. So carry out this information. Now I'm going to the last part of my presentation. That what will happen now, because when we make some studies, because earlier we had made some study of geophysical study at some points, and sometimes we do the point study, sometimes we do that in 2D and 3D and all that. Now let me tell you how do we study that, what data we calculate, we measure. Let's say I'm giving you one example. Here in the field, one makes a measurement of some parameter, and he found two types of values, blue and green, blue and red. And then a person is given this exercise to interpret that. He will say that something is going like that it has got a different characteristic than this side and this side. But the same data, if you see that exactly same data, the other person will conclude that no, it is like this. But both are true given this limited data. Now, but then truth will be only one. The reality will be only one. So how to find out the reality? For that, it is necessary that we should have more data like that. If we have more data, definitely this is wrong, proved now wrong, and this is true. So for that, it is also important that we should, in our study, we should try to see that whether we have acquired the adequate data or not, because otherwise our studies will go wrong. First of all, we have to go for the geoscientific knowledge. Secondly, and what level and what scale, etc. That's the density of data we required. That we'll see. So now, for more density of data, definitely geophysical investigation, we need a special drive, perhaps, because the ground itself, two types of surveys is possible. I'm not going to discuss here so many geophysical investigation is done, because maybe some other time if possible. So here we can find out groundwater by studying its property of resistance, electrical resistance. It's just called resistivity. The resistivity. So if you go for airborne survey, then we have to use the electromagnetic method, because for electrical method, you need the contact. And if you fly, then contact is not possible. And that's why we go for it. So I'm going to discuss with the electromagnetic method. Through the electromagnetic method, what we do, we try to, if you see this figure, this is an instrument that is a loop, only simply generate the electromagnetic wave which goes inside the earth, and it generates the eddy current which reacts with the rock formation over here, and that again generates the secondary electromagnetic wave with the black color I'm showing here, which again comes and recorded by the same equipment there, and when it comes up, it carries the properties of the rocks over there. And that way we can interpret this, if this rock is this or that, depending on the, finally we calculate the resistivity, in fact, or conductivity, you can say. But this method of surveying is very good in the sense it is very fast. It is this equipment attached in the helicopter because it is electromagnetic method, so we don't need the contact, and the helicopter can run about 60 to 80 kilometer per hour speed, whatever we decide. And all this, everything, all the equipment, everything is equipped over here, so everything is done, and you can remotely download the data and interpret that on site also. So we, of course, carried out at 6 places in India. Why 6 places? Because taking out the different geological formation, because each geological formation will have a different characteristics. Now, so let me show very quickly. I'll show you the result because I have to finish the lecture also. This is an area where you have the alluvial, and below that you have hard rock, which is called quartzite over here in Rajasthan. If this survey was not done, the people had to use, of course, the groundwater people have to use that because you cannot use. But then when you drill the bore well, you find the quartzite over there. Quartzite normally is supposed to be hard rock. So you stop over here, don't go beyond. But then with this method, when we have scanned that, because the beauty of this method is that you are scanning the earth actually. You are literally scanning the earth in 3D with very detailed information. So in that case, you could capture that this one, which we supposed earlier to be completely hard rock without any water, is not correct. It has got some spaces also, and water can reside over there. And then with this information, drilling can be done and it can be exploited. Now, this is very important, and we have done the first time in the world, in fact, in desert area in Jaisalmer, because in Jaisalmer, which is desert area, you cannot go inside by foot. So you cannot do a geophysical survey, anything where you need physically to go there. So obviously the airborne survey was the only possibility. We carried out that and we found the result, and I'll just discuss the result. Let's say over here, it has given us the result that the top is completely sand dune, which is red color. Below that, there is a layer which has got the brackish water, very high density, very low electrical conductivity, very high salinity in fact. This one, earlier one. So with this information which we have carried out, a detailed one, the advantage was that earlier, suppose just imagine the same way that you go with a driller, he will drill a bore well, and this this much is almost 50 to 60 meter. So he will drill the bore well. He will, when he touches the saline water, very brackish water, it will say, no, no, sorry, let us stop this because there is no chance of any fresh water over here. But this information will tell him, no, please do go ahead, again drill another 50 meter and go down. You will get a better water than the other one, earlier one. So with this information, this is beautiful. You don't have to try so many bore wells and reject that, and ultimately you get one. Whether you can build only one bore well at the point wherever the information is favorable. So let's move to now a very important again formation is called Deccan traps. These are basalt, and basalt are found all over the world, and it is very complex formation for aquifer system. You see, the basalt is formed by the lava flows. So this detailed information lava flow, and also in between, if there is a fracture or there is a fault or anything else, because such structure will be helpful for us to put water. Because when you put water, normally the basalt, massive basalt, is totally impermeable and it will not allow any water to go inside. So either it is weathered in nature in the top, or it has got a fracture. So these information you are getting very clearly with this scanning, and then you can decide where you want to artificially, forcefully recharge the groundwater, and you will be successful in that case. So this is case of basalt. Now let me come to the alluvial part, which is of course supposed to be simpler rock, but then still a lot of complexity. If you see over this 3D picture, you have a soil cover at the top, the green one, then you have an aquifer, which is a brown one here. Then again you have a very thick soil, and then below that there is a second, and like that there are third aquifer also, which are not showing in the picture over here. But those who are from this region actually is must have heard that the arsenic problem, the West Bengal and the Bihar as well as Bangladesh and even many other countries have suffering with the arsenic problem. Well, I'll not talk to the arsenic problem now right now, but I'll tell how this geoscientific knowledge has helped us. You see, this first aquifer, which I'm showing from the cursor, the ground one, has got severe arsenic contamination. But fortunately, the second one, which is below, this one doesn't have the arsenic contamination in that. When this knowledge was known to the people, people didn't think scientifically, but then they started developing techniques where two aquifers are independent and they can go on pumping the good water without arsenic and there will not be any problem. But if you see that the information which we have got from the Helibon survey, in our geophysical survey, here you find the two aquifers, they are definitely separated by clay, but over here the two aquifers are mixing to each other. There is no separation. The clay had disappeared here, which is quite possible. But the people didn't have the knowledge. Now, if you go on pumping even from here, the water is flowing. So the water from the top aquifer, because of the hydrodynamics mixing, it will come and it will spoil your entire aquifer system with arsenic contamination. So now we are trying to tell the people that pump, but don't pump so much so that this mixing takes place. So this mixing can be avoided. So now this has been possible only with this knowledge. If such a knowledge was not available, this was not possible. Okay, now let's move quickly to another area. It is near Chennai, it is near the coast area, and you can see the coast over here now here. And we carried out again the same Helibon survey by a very detailed one. And we found the result. I am showing you a section here. Here, the present sea is over here, but we find the salinity up to this point. And all these aquifer systems are dipping towards this ocean, which is quite obvious. But then another conclusion we can draw is that perhaps in old days, much old days, perhaps the ocean was up to here, and now it has been moved over down. This is very interesting. I'll show a little more in detail. Coming back to the hard rock, which I have shown you in the beginning itself, the fractured rock and hard rock aquifers actually. So here this survey we carried out through Helibon survey and we got a very detailed 3D total picture. And I will show you. You will feel, like if you are a hydrogeologist, you will feel like you are swimming inside the aquifer actually. So this is a 3D picture, and we got, because you see that all the fracture system in this area, the groundwater remains in the fracture system over here. If you are able to see this picture, there are some blue color. That only the water. Other area we don't have any water in that case, and it is very difficult from the top to find out at 100-meter depth or 60-meter depth that water exactly, because the fractures are in dimension as just a few centimeters or we got every, let me tell you at this point, perhaps I've not told you, we got the in 3D information on the aquifer system at 2.5-meter separation, both vertically and horizontally also, which is too much actually. It's just not possible. You can't do by ground survey actually. So let me show you 3D. You are lying at this point or a top where a lot of greenery is there, of course, no doubt. But let me go down. It was 775 perhaps, and now low. Okay, now I'll go. Yeah, now I'll go something around maybe a few meters down. So you can see 3D that there are some cross section over here. There's some horizontal point. So now you see those pictures which was green totally from the top. You are able to see. Now you are able to see they are not really that green. This much portion only the green. This much portion has changed. The pink and the brown color. And let me tell you that the scale also you can see that the most brown or the dark brown color is the massive rock without any space in that, without any permeability for the groundwater. But then green and the yellow part still have got some permeability and you can have groundwater over there. So you can see now very clearly that there are some channels over here maybe fractures or corrected fracture, but there is something which have a big massive over there, though no water is possible. Now let's go down. Another 40 meter down, another 20 meter I have gone down. You can see a different picture. Another 5 meter down here again. You see very different picture. Let me go further down. And let me go further down. You see the picture is changing. The resistivity is changing. And very clearly now, all these portion where we have more permeability and more water got disappeared. And here is a very big boulder and very hard dark rock. It looks like a very hard material over here. Now let me go at 625. These are the height from mean sea level. So I'm going down, but of course this is for mean sea level is the height only. Now you see with this information, so I'd like to just emphasize that if you carry out the heliborne survey and using electromagnetic, you have such a detailed information that you have gone inside your aquifer and you are seeing each and every point. Of course, this I have shown some cross section. You can make another cross section also. You can make this way. You can cut a slice. Everything is possible. But what you see over here, no chance of any water over here. But the lot of water is still at the depth of say more than 100 meter because I started from 770 and now we are at the 625, so around 150 meter deep I am right now. And I'm finding some water over here, some water over here, some water over here, some water over here like that. Okay. So I'm now coming to ending my lecture, in fact, by a final message that the impact of climate change on water resources is generating more surface water and less groundwater. So this is harmful for you. So you need more groundwater and less surface water, or you have more surface water, I don't mind, but you need more groundwater because groundwater is only, that's why my first point is here. You have to conserve the rain because rain is the only source of water. Of course, snowfall also is there because I'm sitting right in Kashmir, but then this is also precipitation. Both are called rainfall and snowfall together called precipitation. So what you have to do, you have to conserve rain, and there is a Ministry of Jal Shakti of Government of India has also shown as catch the rain where it falls, when it falls. So because very less time rain comes to us, and very few places it comes to us, so we have to catch it. If not 100%, it is 90% 95%. And then because that is all needed, and that you have the second part will be that you have to store that into the groundwater. So you have to capture the first part is capture the rain. That there are ways that you can do that that is easier work. But the second part, which is that you have to store that inside the subsurface as the groundwater. For that there are some ways, but the thing is that you need the geoscientific knowledge. Without geoscientific knowledge, this experiment will be failure like that. Of course, that is the to explain the technology and finding to understand. Of course, for this purpose, farmer have to come into picture. Society have to come forward because only scientists cannot do that. Scientists can provide only the geoscientific knowledge, but then work has to be carried out. Implementation has to be done by the society, by the farmers. So that's why the technology has to be explained to them in a different language. And what you have to do that, make the groundwater visible. Because groundwater is invisible normally, and it has to be made visible by technology, because I have shown you the technology. By heliborne survey, let's say, is very advanced technology. There are many more things also. So by technology like say remote sensing also helps a lot sometimes. But much more is important to putting the water into the mind of the people like this. So thank you so much. I'll complete my talk over here and open to the question.
Thank you so much, sir. Such a wonderful presentation. I mean, like, the work is like mind blowing. It's awesome. The way you have shown us the 3D diagrams, like we feel that we are inside the aquifers and can see the heat there and the water stored there. I mean, like, it's just amazing. I have no words to thank you for such a wonderful presentation. And I'm very sure that our youngsters would have got a lot of benefit out of your presentation. I see only 30 participants, but still I think the one who has not joined are big loser today because we had really, really wonderful lecture series today. So thank you so much once again. I would like to talk to you sometime because I have a lot of questions for you, just not the questions. So maybe I would like to you in detail sometime, sir. So I would now Any of youngsters, if you have questions, please raise your hand and ask, or type them in the chat box. It's such a fantastic work. So I will really appreciate if you have more discussion on this work. The young people, the young researchers.
I would love to do actually. I couldn't ask you the question the way it was there, but then I definitely like to have discussion. And people can perhaps there is a question from Sarah Kazi. I'm seeing here.
Yes.
Okay, let me read the question. It is in the chat box. Yeah. Sir, with respect to climate change and extreme weather pattern, how to balance groundwater usage and sustainability in semi-arid regions? Yes, sir. So, Dr. Sarah, if you are listening, well, this is what I told that we have extreme weather pattern is there, which will generate more surface water and less groundwater. So it is now our duty. We can't depend on the nature simply, because actually why this is imbalance is because of the population. In fact, for our country, but as a matter of fact, for all other countries also, the groundwater has been decreasing and the surface water is increasing. The surface water increases make the flood. So of course we have to forcefully generate the groundwater by artificial recharge, which is called artificial recharge, and manage artificial recharge. And sustainability can be judged, of course, by if you simulate the groundwater flow. When you simulate the groundwater flow, you can understand that what is going to be condition after 5 years, 10 years, or 20 years. It depends on the model. So that way, you can ensure the sustainability also.
Any other questions? Okay. Uh, okay. So she says thank you, and then yes. So if we do not have any further question, we can move towards our next presenter. And I would like to thank you again, sir. Thank you so much for such a wonderful lecture. Thank you. And then now, thank you, sir. Now I would like to request. No, one more question. Sir, one more question for you.
No problem. I'm here only. Even after this talk, also I'll be here.
Okay. So maybe if you can answer this, there are few questions from Kashmir Valley. So
where is that? Is it chat box? No, I don't see any question in chat box. Oh yes, one more there. Yeah, one more there. Sir, more groundwater being pumped out in Kashmir Valley. Will it have any substantial impact on the surface water resources, particularly its use in agriculture and allied? Of course, yes. The answer is yes, because you see the surface water and groundwater are normally connected. But since you're talking about Kashmir Valley, it will have less impact because Kashmir Valley, the surface water gets its source from the glacier also, and the snow melt. Rather, if you come to the South India plateau, the river water comes only from the groundwater in the lean season. So there it will have much more impact. Here it will have less impact.
Thank you, sir.
Okay.
Yeah, thank you. So you be connected with us. I think you may have a lot of questions at the end of the session because we have kept minutes for the student. They can ask questions or the young researchers. So now I would. Yes, sir. Thank you so much. So now I will invite Professor Parveen for her lecture. She will be talking about the impact of climate change on the long-term trends of meteorological phenomena in Iran. So Dr. Parveen.
Thank you so much. And I'm so sorry for there was an issue for my first presentation. And now I'm in the west of the world and time is the 3 a.m. I'm very pleased to speak in this meeting, in this valuable meeting. My topic is the impact of climate change on the long-term trends of meteorological phenomena in Iran. Climate change is the main issue these days and is significantly impacting the frequency, intensity, and duration of extreme weather events around the world. And climate change and extreme weather events due to climate change, for example, more heat waves and extreme heat, higher temperature, a warmer atmosphere lead to more frequent and intense heat waves. This increases the risk of heat stroke, wildfire, and agricultural losses. And warmer oceans absorb much of excess heat, leading to marine heat waves that harm marine ecosystems and contribute to coral bleaching, increased heavy rainfall and flooding. This leads to more intense rainfall events, increasing the risk of flooding, landslide, and damage to infrastructures. And change in atmospheric circulations. Climate change can alter weather pattern, leading to prolonged periods of heavy rain in some regions and more severe drought. Higher temperature increase evaporation, leading to drier conditions in many areas, especially those already prone to drought. And the change in precipitation pattern, climate change can shift rainfall patterns, making some regions drier and more susceptible to drought. And stronger hurricanes and typhoons. Warmer waters provide more energy for hurricanes and typhoons, leading to a stronger storm with higher wind speeds and heavier rainfall. And increase wildfire risk. Climate change create ideal condition for wildfire by increasing temperatures and drying out vegetations. And also more extreme winter weather. A warming Arctic can disrupt the polar vortex, leading to more extreme cold spells and winter storm in some regions. Let's get back to our discussion about the impact of climate on Iran's weather. Iran has a diverse climate with many different regions, including arid and semi-arid areas, subtropical regions, and mountain regions. Here you can see the Alborz Mountain and Zagros Mountain. It has very complex topography. Some areas are desert. For example, in this part of Iran, we have deserts, while other covered with dense forests. For example, in the north of Iran, we have forest. And some parts are arid and semi-arid. The majority of Iran is arid or semi-arid, with the average annual rainfall being around 240 millimeter. The main rainy season is from November to May, with little to no precipitation from May to October. The two main deserts of Iran, for example, Dasht Kavir and Dasht Lut, receive less than for 50 millimeter rain annually. And in subtropical area, for example, the coastal area of the Caspian Sea, um, we have the forest and the subtropical climate. The north edge of the country is humid with temperature rarely falling below freezing. And mountains areas, Zagros and Alborz mountains, are vast and reach over 5,000 meters in height. In some areas, the higher mountain valleys receive more precipitation, with the Zagros slopes receiving more than uh, 500 millimeter of rain annually. At high latitudes, precipitation falls as snow. And the coastal plain of the Caspian Sea, this area receive more than 1,500 millimeter of rain annually, with rainfall distributed relatively even throughout the year. The southern coastal plain of the Persian Gulf and here and the Gulf of Oman have mild winters and very hot, humid summers. Iran's climate is colder than neighboring countries like Iraq and Turkmenistan due to its higher elevation. Iran has experienced experiencing climate change with increasing annual temperature and greenhouse gases emissions. This is leading to more frequent and intense extreme weather events such as drought and floods. In this picture, you can see the systems that can affect the Iran's weather. Iran's climate, especially in winter, is influenced by western cyclones from the Black Sea cyclones. Additionally, the northeast and north of Iran, affected by the Siberian high, especially in the winter, and the southeast of the Iran is influenced by Indian monsoon. Many hazardous weather phenomena occur in Iran. For example, floods happen in almost all region of Iran. Several tropical storms have reached the Iranian coast of Makran area in the last 20 years, which is unprecedented. Examples include Cyclone Gono, Cyclone Fed, and Shaheen. One of the important factors that cause tropical storm is the increase in sea and ocean surface temperatures. One of the conditions for the formation of a tropical storm is that the surface temperature of the oceans or seas must be above 26 degrees Celsius. And also, we have lake effect snow. Lake effect snow occurs on the southern coast of the Caspian Sea every few years, with snow depth exceeding 1 meter, causing trees to break, power outage, and road blockage. Additionally, in recent years, the phenomenon of water spout has been frequently observed in the Persian Gulf. And also, heat waves in many parts of Iran are occurred, especially in recent years. Iran is experiencing unprecedented climate related problems such as drying of lakes and rivers, dust storms, record breaking temperatures, drought, and floods. This image of Lake Urmia was created using Modis products due to excessive use of groundwater and construction of 50 dams on the rivers. This lake dried up within a few years, unfortunately. The trend of snowfall in the Lake Urmia basin trend in the number of showerly rainfall, indicating a change in the precipitation pattern in the Lake Urmia basin. One of the consequences of climate change is the alteration of precipitation pattern, which tend to decrease systematic rainfall and increase shower events. This can lead to flooding in some areas. And in this slide, you can see the trend of minimum temperature anomaly that changes a decrease of increase of 0.24 degrees Celsius per decade, while the maximum air temperature has increased by a much larger 0.64 degrees Celsius. And of precipitation change is decreased, but this trend is not significant. This figure displays wind speed and direction of hurricanes across the country. Iran, this suggests a large speed and direction
Hello.
and pattern on days with the coldest temperature in
Okay.
northwestern Iran. And
Library.
he shows the wind pattern on days with the hottest
Agalo.
temperature in northwestern Iran. The jet stream is generally stronger and more prominent in winter than in summer. The jet stream seems to shift northward and intensify during cold extreme, as you can see in
Bhola.
this figure. And by studying
वो
the
LSR.
behavior of the jet stream, scientists can potentially improve forecasts of heat waves and cold spells.
अब कोची कोची में रखे के पड़ते तब वो बताते ना.
Earlier, heaviest snow occurs on southern coast of the Caspian Sea every few years due to the sharp temperature difference between the warm lake and the cold air, as well as the presence of Alborz mountain range. As you can see, the snow in February 2005 reached about 1.5 meter. With global warming, the surface temperature of the lake will increase, and this temperature difference will affect the intensity of this phenomenon. Another meteorological phenomenon that has unfortunately increased in frequency and intensity in Iran is dust storm. In this image, you can see the desert inside and adjacent of Iran, desert in Iraq, Syria, and Saudi Arabia cause the most dust storm in western and southwestern of Iran.
हाँ हाँ रंगोली जहाँ से बस मुड़े टिल्टा में.
And as you can see, the most dust storm occurs in southwestern and western Iran. This dust is carried to Iran by westerly winds from neighboring countries. And here in the Tabas region, near the deserts, dust storms are local. These figures present data on dust event in Iran gathered from 111 weather stations across the country. And here you can see both dust frequency and the number of dusty days peak in the summer months, July, June, and July, and there is a clear seasonal trend which dust activity increasing from spring to summer and then decreasing toward winters. Dust event frequency and the number of dusty days follow a similar pattern, indicating a strong correlation between the two. And there is noticeable year-to-year variation in both dust frequency and the number of dusty days. And here, both measures shows a general increasing trend over the 20-year period, suggesting a possible increase in dust activity in Iran.
भैया को भी रखेंगे.
And as I mentioned at the beginning of my talk, several tropical storms have reached the southeastern coast of Iran, the Makran area, in the past 2 decades. One of them is Shahin storm on September 29, 2021,
दूर होने
Cyclone
चलते कम
Shaheen
से कम 3
attained
राउंड
significant development in the Arabian Sea.
तो चाय
It
कम से कम 3 राउंड
proceeded
चलता है
to across the Gulf of Oman
चाय कम से कम चाय
on
तो सबके
October
पटेगा
3,
25
causing
या 75 कप नहीं
substantial
15 या 45
economic
50
damage and cost and casualties due to the heavy rain and high waves it generated using meteorological and satellite data measuring the physical and chemical properties of the water column by
11:30 बजे बांट
CTD a
देना
few
है जब
days
उनका
before and
मेथोडोलॉजी
after the
चलेगा ना
cyclone and coastal observations. We
हाँ
analyzed the impact of Cyclone Shaheen
हाँ
on the
हम लोग भी अपना अपना कैंडिडेट
northern
बुलाएंगे
shelf of the Gulf of Oman in
सुबह
Iran.
आएगी एगो सुबह
Before Cyclone Shaheen passed on September 29, sea surface temperature in the northeast of Gulf of Oman were around 31 degrees Celsius and near Chabahar located in this area. Near the Chabahar, they were about 29 degrees Celsius. The SST in front of the cyclone was about 3 degrees Celsius higher than the long-term average, which helped strengthen the cyclone. After the cyclone passed, the SST decreased by around 2 degrees Celsius. By October 2, the SST behind the cyclone was negative compared to the average, while it remains about 1.5 degrees Celsius above average in front of the cyclone. 2 days later, the SST dropped to 27 degrees Celsius, indicating a cooling effect after the storm. Here you can see the cooling effect after the storm passed from this area. Although some changes in the trend and intensity of meteorological parameters and phenomena are to alteration in land use and drying up of lakes and wetlands. Unfortunately, in Iran, the role of global warming and climate change should not be overlooked. Climate change is a major driver of extreme weather events, and its impact are already being felt around the world. Addressing climate change through mitigation and adaptation efforts is crucial to reducing the risk and building resilience to these increasingly frequent and severe events. Thank you so much.
जैसे में वो बंटवारा होगा ना वही टाइम पे ओकरा लाना है ओकरा से सर लोग को दिलवाएंगे आधा
Thank you
मास्टर
so much,
कंफ्यूज
Dr.
ओकरा
Parveen,
सकल
for
देख
such a
के
wonderful presentation.
और
Something
जरूरी
that
है
may
ना
not have much idea about how the Iranian part of it is doing in
मतलब सही
case
रहेगा
of Indian summer
भी आएगी
monsoon and
आपका
any
रहेगा
Mediterranean region. They are reacting or how they are influencing the Iranian part and the Indian part. It's a wonderful study, and I think for our youngsters also the way you have explained it in a very simple way, they would definitely have been benefited out of your presentation. So now I invite the youngsters to raise their hand for any questions or
मतलब वो आएगी और
yeah,
कहेंगे
so we
सर लोग
have
अरे
one
लौंडा
from
लोग को मत
Professor
पूछो पर
Shakti
सर लोग
Ahmed.
को दो
Ma'am, you have very high rainfall around 1000
खाली
millimeter
सर लोग
per
को देने
year
के
in
अब
the
आधा मास्टर
northwest
कंफ्यूज की
Iran.
क्वेश्चन पूछे
Also,
कि साला
you
ये है
have
कौन
karst formations running from north to south at your western border. Since karst formation have very high permeability, have you made any study if that rainfall throughout the karst formation are draining to the Persian Gulf? If so, that can be captured and utilized within the country.
Yes, thank you for the good question. The precipitation amount in Iran is very different in different parts. For example, in the Anzali city. In a year, we received more than 1,500 millimeter precipitation due to the role of the Caspian Sea and also Alborz Mountain. The Caspian Sea is warm, and the cold weather comes from the Siberian High and also comes from the North Pole in the winter, and due to the strong uh, instability for interaction between sea and air, we have a strong instability, and we have more evaporation from the Caspian Sea, and we have the uh, heat. In this area faces to high precipitation in summer, and also a snowfall in winter. And in the south of Iran, for example, Persian Gulf and the Gulf of Oman, the amount of precipitation is very low. And in the desert area, the precipitation is about less than 50 millimeter, because there is no humidity, and there is no mountains and for rising the moist air, and the climate are very different in many parts of Iran.
Yeah, the question here is like what Professor Shakil Ahmed is asking you. You have a lot of karst sediment, the carbonate sediment. So the precipitation, what is happen in Iran, can we capture it in those aquifers? Because they are the very good aquifers, as well as the water, underground water is concern. So he's asking whether we can capture and utilize that particular water which is coming due to the precipitation within these karst sediment, within these karst aquifers, and can we utilize in your country, like for
Yes.
especially for the groundwater.
Yes. And also another question is about the snow depth compared to rest of the years in the Caspian Sea. It's due to lake effect snow. I published more than for ISI paper about the lake effect of the Caspian Sea. This snow is related to the lake effect snow and occur few years in Iran. If you want, I can send you my papers, and I explained and also simulate the role of the Caspian Sea and the difference air temperature between the Caspian Sea and the air temperature that cause this phenomena.
Okay, maybe we can take this later. And then there is another question by Dr. Sarah Kazi. She's asking that in the year 2005, we noticed more snow depth.
She already replied that.
Massive calamities on when occurs.
Unfortunately, in Iran, due to construction of a lot of dam, and we faces with dry area, and when the wind blowing, the dust storm occurs. And also in the neighbor countries, for example, Iraq, Syria, due to the wars and destroying the plant area with blowing the dust, with blowing the wind, the western and southwestern of Iran encounter with the dust storm. And unfortunately, these days there is no policy for controlling and for manage the green belt, and there is no policy for control this event, unfortunately.
Yeah, there is another question, I think. Dr. Niga, you want to ask something? Your mic is on now. You can unmute yourself and ask the question.
C'est aussi être prêt à apprendre, à écouter et à grandir constamment. La marque M est un rappel que, même si vous éclairez le chemin des autres, il est crucial de rester ancré et de reconnaître que votre force provient de quelque chose de plus grand.
Professor Vishal has got his hand raised.
Yeah, and probably.
Mais une opportunité d'utiliser votre influence.
But somebody is speaking somewhere.
Yeah, Dr. Niga was speaking, but we are unable to hear him. So we have unmuted you. Maybe you just try. We'll try later to connect with you because your voice is not very clear to us. Professor Upreti, if you have any questions. Professor Vishal Upreti.
I think he raised the hand much earlier. Now he's not available, perhaps.
Professor Vishal Upreti.
No, he can able to unmute.
He has raised his hand.
Before only.
Oh, sir, it is an old one. The previous lecture, he raised his hand. The first one, I think. So, is there any other questions from the audience? Young researchers, get up and ask something. Such an interesting lecture, and then you have a different terrain to discuss about. Iran. Anyone? Yeah, there is, I think.
Thank you.
Thank you. So, if Martin Shrestha, yeah, Professor Martin Shrestha, yeah, please unmute yourself and ask your question.
Did I raise my hand?
Yes.
Okay.
Okay, I did. Okay. Yeah, I think it's not a question, but I'm really happy to hear so many marvelous, the presentations, ranging from, from the Iran to, the Iran, Indian. But I'm interested in I was really impressed by the presentation by Nana Silam, and because I'm interested in how the some of the global phenomena is going to affect the small countries, even Nepal. So I think maybe I will talk a little bit tomorrow on that one, and I'm really happy to see the dynamics behind the effect of these global phenomena to India and the neighboring, the South Asian countries. So I think I don't have much questions, but I think it would be better. I think our young scientists come forward and ask their queries. Thank you.
So people, like one of the person wrote you that we got many things as a young researcher, ma'am. Thank you so much. This is for Parveen.
Thank you. Thank you. It's a great pleasure for me to attend this meeting, and I can share my papers with the young scientists if they want. and they can send me an email and ask any question about the Iran's weather and extreme phenomena and the effect of climate change on them. I'm also thanks from the organizer of this meeting. Thank you so much.
So much, Praveen. And we will share your address with your due permission to our youngsters. So if they want to write, they are free to write to you. Okay, I'll share your address with the participants. And if we do not have any other question, I thank you once again, Dr. Parveen, for such a wonderful presentation. And we have a special session now, a small session for a few minutes, like maybe about half an hour. So it is on observations and experiences of climate change impacts, such as extreme weather events, seasonal shifts, and environmental changes in the respective regions. So any young scientists or researchers from the audience would like to talk about their own experience they are facing under this climate change scenario. So we will really appreciate if you can just raise your hand and talk about what sort of changes you are feeling in your country or your region where you are staying, like you have grown up. So have you seen any changes in your region when you are growing up, and what kind of changes and what do you think they are associated with? Even if not that, at least the kind of changes you are facing in your lifetime. If you can explain us that, we will appreciate your efforts. You're free to raise your hand or write on the chat box so we can ask you to unmute yourself and you can talk for a few minutes, 5 minutes maximum. Yes, Dr. Sarah. So please unmute yourself and say something about your region, that regional changes or your experience.
Yeah, I grew up in Kashmir and I'm still based here. So what we are experiencing here is that more heat waves and more snow droughts. So it was unheard of in a setting like Kashmir, particularly the heat waves. So we are also witnessing the snow droughts, which obviously affects our water resources. The discharge of the rivers has significantly reduced. So these are the changes what we are observing in our natural system here in Western Himalayan type of climatic settings and this type of environment, which I have observed personally. I have few projects where I'm working on this. So they have been funded recently. So let's see what results do I get.
Yeah, sure. So do you have any study to share with us right now? You can switch on your camera, Sarah.
Yeah, I'm working on it. Thank you. I'm working on it, but currently I do not have any study which is linking the extreme weather patterns to I'm working on groundwater resources, the impact of climate change on groundwater resources. So I could, the projects have started recently, so I cannot share it right now. But yes, we are, previously I have worked on base flow, the role and importance of base flow in sustaining the river discharge. Base flow has also reduced, so that is also changing our river discharge.
So it is
significantly reduced.
Okay, so it is a seasonal variation what you see, or throughout the year, like you say that the river discharge is throughout the year?
No, not seasonal. No, it's not seasonal. It is the trend which we are observing from past. If I only talk about river discharge, then from last 10 or 20 years, we are noticing a declining trend in the river discharge.
You have not seen, or you have seen the decline?
Yeah, it's observed.
Okay, you have seen it. Okay. Thank you, Dr. Sarah. Now we have another person, Dr. Atul. Dr. Atul?
Atul also raised the hand.
Yeah, Atul also raised the hand. Yeah, please Atul, first you go ahead. Please unmute yourself and say. So.
Hello, good evening. Actually, presently I am staying in Shillong. So, like I have been staying here for last 1 year or so. So, what I have been told by my senior colleagues over here, they told me that if they keep water in the months of October or November outside, then it will freeze. But now, like there is no such phenomena happening. So basically, because of the warming effect, overall warming, it is happening. And the second thing which I have observed, like I have I was staying in UP for during my childhood days. So the peak of the winter was the winters started during mid of December. Let's say from 15th of December, the winters will reach their peak. But now it has shifted, like 15 days shift is there, and now we experience the winters from, let's say, when in the beginning of the January. Similar kind of thing I have observed, like with the ripening of the mangoes. Mangoes will ripe around 15th of May, let's say 15 years back. Now they ripe around 1st June or something like that. So there is overall warming as well as there is a shift in the summers and winters that I have experienced or observed.
Okay, so do we have any expert here in our speakers, Professor Srinivasan, or anyone who want to talk a little bit about the shifting of the seasonal shifting of the pattern, like especially the summertime and winter time?
Yes, I think in many parts of the world, there is a shift in the seasonal cycle. The snowfall occurs much later, and as pointed out by people, in Himachal, for example, the apple orchards yields have gone down because of high temperatures. So they are going upwards in Himalaya. They are not growing apple at the lower levels, but at upper levels. So this is happening all over the world. The shift in the seasonal cycle due to temperature change mainly.
You got your answer, Atul?
Yes. Thank you, sir.
Thank you, Atul, for your concern. And then we would like to ask Dr. Kumar Rishikesh, who has raised his hand. Please unmute yourself, Kumar.
Yes, ma'am. Greetings of the day, everyone. I am currently I'm first year PhD student, and I am working on impact of climate change on rainfall shifting. So my concern is that in initial stage, I found that the pre-monsoon and post-monsoon rainfall has shifted in my study area. So I think I am unable to get the conclusion, like concrete conclusion. What is the major causes of that to shifting pre-monsoon and post-monsoon rainfall? So I want to answer that question. Thank you.
Yeah. Professor will answer. Professor Srinivasan. Sir, please unmute yourself. Sir, your mic is muted. Professor Srinivasan, J. Srinivasan. Sir, your mic is unmuted.
Mike, can you hear me?
Yeah. Yes, sir.
Yeah, I want to know from Kumar, which is the area he's studying? Which area he's talking about?
Sir, I am currently, my current study area is Jharkhand, sir. Jharkhand state in India, sir.
Yes, if you go look up Mausam, there are lots of papers published about each state in India. So you should look at all the data around Jharkhand. Chhattisgarh, Jharkhand, Odisha, they will have similar pattern. Okay. Now we know from the data of the last 10 years that rainfall has declined in this area over the last 15 years. Okay. There's a steady decline in rainfall in June, July, August. But there are not many papers about pre-monsoon and post-monsoon. Okay. But since we have greater data available, there are papers published So you can look up Mausam, or you can send an email to Dr. Rajivan. He will tell you who all have published papers related to Jharkhand. Okay? Because yours is a small area, the variation may be different from the rest of the region. So, but you must remember, as you go to a smaller region, it is much more difficult to explain the causes because there are natural internal variations. And of course, there's a long-term trend. So as you go to smaller region, it's much more difficult to identify the impact of climate change. Okay? When you go to smaller region, like for example, take the city of Bangalore, the rainfall pattern here changes due to urbanization, not due to carbon dioxide. So as you go to smaller region, you have to worry about deforestation, and Jharkhand has a serious air pollution problem, aerosol. So all those will start playing a role as you go to smaller scale. But there's a lot of work going on. You must get in touch with IMD and Dr. Rajan to find out what other work has been done in your region. Okay?
Sir, thank you, sir. And thank you, panelists.
Thank you, sir, and thank you, Kumar, for raising these kind of interesting questions. So now we have Dr. Mafta Ul Safe. He has raised his hand, so please unmute yourself and ask. Dr. Mafta.
Okay. Good evening, everybody. I am Dr. Miftaul Shafiq. I am assistant professor currently based in Kashmir. I will just add on to what Sara ma'am had to say regarding the climate in the Kashmir Valley. Yes, we are experiencing a significant shift because we live in the western part of the Himalayas. And I will add just one point here that yes, we are seeing a significant seasonal shift in Kashmir Valley, especially around about 15 to 20 days shift. We are, as Sara ma'am has already said, that we are seeing the snow droughts in this area. We are seeing an untimely rainfall in this area. Oh yes, climate changes. There are visible impacts in our area as well. But I will again focus on two important points here, which I raised yesterday as well. One is that I am actually into the impact part of the climate change. So we have done a lot of work with respect to the observations in the Kashmir Valley. Maybe the seasonal or long-term changes in with respect to climatic variables. We are seeing shift in almost all the variables of climate change. But my focus here is that we are actually working currently on the perception of the climate change, that whether people perceive it or not, especially in our area. So from last 2-3 years, we have been working on it, and most probably we have published 2-3 studies regarding it, and most probably we will be publishing another part of it. So what we have seen is that the impacts of the climate change are visible there, but people have not been able to perceive it in a significant manner. Obviously, there is a shift in the land use. There is a shift in the irrigational pattern. There is a shift in the how people are doing their agricultural activities in our area, especially with respect to, for example, in Kashmir Valley, most of the people were doing the paddy cultivation, but now most of the people have shifted to the this horticulture, especially apple. Now, when we look at the economic impacts of this, there are huge economic impacts with respect to the apple, but the triggering factor was the climate. Climate change was the triggering factor for this change. But people are not perceiving it at the ground level. So we need to. I have just asked yesterday. I have taken classes with the Srinivasan sir in the IIC Bangalore. So I just asked yesterday that in 2018 I asked this question to Srinivasan sir in IIC Bangalore that we need to include more and more social scientists with respect to the climate change debate. Yes, Srinivasan sir answered it in very well manner that we need to first teach them the climate change, but we need to include. It's my personal observation that we need to include more and more social scientists so that people perceive it, so that people get a feel of what climate change is and how it will impact them over the period of time. Thank you, ma'am. Thank you, sir.
Thank you.
Yeah, Dr. Mifta, your point is very well taken. Let me tell you, at least in South India, I know there's a difference between urban and rural. Rural people understand climate change better than urban, because if you're involved in agriculture, in field work, you see in urban areas, the perception is not that good. I don't know about Kashmir. In Kashmir, Is there difference between urban and rural in perception?
Yes, sir, there is a significant difference.
Yeah, that's a big problem. Secondly, your point about social science is correct, but still, I'll tell you what the main problem I've seen in IPCC. The people in climate change want to quantify everything because that's easier to explain. Social scientists don't like it. They go by more qualitative measures. So there was a big gap between working group 3 and working group 1 about how to talk about climate change. Because social scientists are very, very not comfortable with quantitative criteria, quantitative discussions. They bring in qualitative issues into account, which makes it difficult to compare different views.
Thank you, sir. Thank you.
Okay.
So now another speaker is Dr. Ayush Bishwas. Please unmute yourself, Ayush, and then.
Good evening, everyone. First of all, thank you so much, ma'am, for creating this opportunity so that everyone of us get a chance to speak our views on this particular aspects.
Excuse me, Ayush, your voice is disturbing. Like we have a lot of disturbance in your voice. Can you just repeat the thing what you said? And or if you have some electronic device close to you, you can just keep them little away from you so that we can hear you properly.
Is it clear now?
Yes, yes, yeah. Please go ahead.
So good evening, first of all, everyone. Thank you so much, ma'am, for creating this opportunity so that every one of us, get a chance to speak our views on this particular aspect. And I wanted to share, ma'am, a very interesting segment when we talk about climate change and every aspects of this. I'm from Chhattisgarh, basically. And from the last 5 to 6 years, we have been noticing a very strange pattern when it comes to stargazing. I myself love to, to deal with telescopes, and I love to watch stars and moons. So, like few years back, I still remember the same telescope which I used to stargaze. I remember I was trying to spot out the planet Neptune. 5 years back, I was not at all facing the problem to plot out that particular planet because of its celestial tracks and celestial coordinates. But nowadays, it has become much more, difficult task to watch your favorite star when it comes to stargazing. Because of altered wind patterns and excess of the celestial coordinates,